So, congratulations, Gen Chem friends. Congratulations to making it to the last lecture of this chapter and the last online lecture for material that's covered on the Unit 2 exam. And in this little vignette, we're going to talk about the differences between the terms diffusion and effusion. We tend to use them as synonyms, but they really scientifically mean two different things. Diffusion of a gas speaks to the spread of a substance throughout a particular space. So when you open up, if you have a gas molecule in an area, when it's moving around and spreading around, that is called diffusion. That's a little bit different than this term of effusion. Effusion is specifically the escape of gas molecules through a tiny hole into a space. So if you were to open up a bottle of perfume, typically we would say, oh, the gas molecules that smell diffused into the air. Well, technically, the term would be effusion because those gas molecules, that smell, is going through a small hole, the opening of the perfume bottle, into the atmosphere. So that is effusion. And we can, we can calculate rates of effusion using this Graham's law of effusion, which basically says the ratio of rates, the speed at which a gas effuses, is equal to the ratio of the square root of the inverse molar masses. So let's end our time together with this chapter doing this example problem, which is similar to one on MindTap. We have an unknown gas composed of homonuclear diatomic molecules. So that's just fancy words for saying, okay, we know this is a diatomic molecule. And it effuses at a rate that is this many times greater at the rate at which oxygen gas effuses at the same temperature. Calculate the molar mass of the unknown. So let's break that down a little bit and write down what we know. So we're looking for a molar mass of the unknown. So let's just call that M1. We don't know what that is. We'll call it X. The gas that it is being compared to is oxygen, so we'll call that M2. We know its molar mass from the periodic table, 32 grams per mole. I don't know specific values for either rates, but I do know that the rate of the unknown gas, R1, is 0.355 times greater than the rate of oxygen. So I can take that statement, make a little mathematical expression. Using that and the information about the two molar masses, I can do some substitution into that Graham's law of effusion. I don't know my rate 2, but I can get my pen. I can do a little bit of algebra and say, hey, that rate 2 and that rate 2, they cancel. So I'm left with just 0.355 on one side and then the square root of 32 over x on the other side. I can get rid of that square root on both sides by squaring both sides. Doing that, this equation devolves into what is here on the right. Then doing squaring and cross multiplying, I can find the molar mass of my homonuclear diatomic molecule as 254 grams per mole. So, congratulations again for making it through this chapter and this unit. And this is the end again of chapter 10.